Okay, so in today's video, we're going to be talking about metals, nonmetals, and metalloids, their physical properties, and where they can be found on the periodic table. So first things first, physical properties. A physical property is a characteristic of matter that can be observed or measured without changing the identity of matter. So let me break that down. A physical property is something that you can look at or measure or find out from a substance without changing what the substance is. Now this doesn't mean state of matter. You can take water and melt it, it's still water, right? If it's ice, you can melt it, it's still water. That would be a physical property. You're not changing what the matter is, it's still water. So this could include testing the substance for different properties. You can be looking at it, you can cut it in half and see what happens, but you're not changing what the actual substance is. It still remains the same thing you started with. So these are very simple things to find out. It's usually a yes or no, and they're not usually very hard to find out. Physical properties. Okay, so let's talk about some of the physical properties we're going to look at in class. First is conductivity. Will electricity or heat pass through it? So if electricity passes through it or heat passes through it, then it's said to be conductive. So think of like your mom's stainless steel skillet. Heat passes through it from the burner through the skillet to the food, so it's conductive. Also, think of copper wires like that plug your TV into your cable outlet or in an electricity plug. Electricity passes through those, and so those wires are said to be conductive. Next, ductility. Speaking of wires, if something is ductile, it can be stretched into thin wires. It can be stretched super thin and it doesn't break or come apart. So it's ductile, it means wires. Next is malleable. This is when it can be hammered into thin sheets. So when you see malleable, think aluminum, because we can hammer that into thin sheets of aluminum foil. Okay, aluminum is not the only element that's malleable, but it's a good example to remember. So malleable, hammered into thin sheets. Luster is how the surface looks under light. So if you shine a light on the substance, what does it look like? Is it shiny? Is it dull? Is it sparkly, like metallic? Does it have a pearl finish? There are several different descriptions for luster. This is what the surface looks like. Okay. Next are physical properties. There are three more. First is magnetism, and this one's pretty basic. Are magnets attracted to it? Yes or no? Iron is definitely magnetic. There are other elements that are too. So a magnet will stick to it, then it's magnetic. State of matter. So at room temperature, is it a solid, liquid, or a gas? So at room temperature, oxygen is a gas. At room temperature, iron is a solid. So we look and see, is it regular temperatures, what state of matter is it? And then lastly, brittleness. If it breaks or shatters when it's hit with a hammer. So if you smack it with a hammer, does it just dent? And that would be not brittle. Or does it break and shatter into pieces? That's brittleness. So brittleness is if it breaks or shatters when it's hit with a hammer. Okay, so why are we going over all these properties? Well, we're going to use those properties to put our elements into three different groups: metals, nonmetals, and metalloids. The first group is metals. It's the largest group of elements. Metals are usually conductive, so they can pass heat or electricity. Ductile, they can be stretched into wires. Malleable, they can be hammered into sheets. Shiny, magnetic, solid at room temperature, and not brittle. So most metals, when you smack them with a hammer, they dent, they don't break or shatter. Notice I say usually, okay? We'll get to that in a second. Nonmetals are usually non-conductive, so heat, electricity does not pass through them. They are non-ductile. They cannot be stretched into wires. They are not malleable, because if you hit them with a hammer, they won't go into sheets, they just break. They're usually dull, if you can see them at all. They're non-magnetic, so magnets are not attracted to them. They can be any state of matter at room temperature. A lot of nonmetals are gases at room temperature. But there are some solids and there are some liquids. And then they're usually brittle, which means that they're not malleable. These two kind of go together. If they break when you hit them with a hammer, then they can't be hammered into sheets. So if you smack a solid nonmetal with a hammer, it's just going to shatter. A lot of nonmetals are gas, so you can't even hit them with the hammer because you just go straight through it. And then last group is metalloids, and they're kind of the oddballs of the element world. They have some properties of both metals and nonmetals. So they're a little bit metal, a little bit nonmetal. They have properties of both. So a metalloid could be conductive and ductile, but be dull and non-magnetic. So they have some of these properties and some of these properties. So they're a little bit of both. Now, notice on here I underlined usually. Some elements are considered metals even if they don't have all of these properties. We group them as best as we can. It's not perfect. It's not a perfect science. So like, for example, in metals, mercury is liquid at room temperature. Aluminum is not magnetic. So there are different metals that don't match all of these, but they match most of them, so the group they fit in the best is metals. For nonmetals, there are examples as well where they don't match the properties that most nonmetals have. But if they fit most of them, then we put them in this group because it's as good as we can get. Metalloids, those elements, they don't fit in either one of those because they're very much not like metals, but they're not really non-metals either. So they kind of go here. They're kind of a gray area. And then lastly, we can also use the periodic table to tell us more or less what group an element is in. So I drew an example, it's not perfect, of a periodic table. I'm going to show you where they're found. So the biggest group is metals, and they are in the middle and left-hand side of the periodic table, except for hydrogen. Hydrogen's up here in the top left-hand corner, and it's a nonmetal, and it hangs out here by itself. It likes to hang out with the metals, but it's a nonmetal. So metals are in the middle, left-hand side, and then go over kind of close to the zigzag line. So metals make up the majority of the periodic table. If you remember, I pointed out on your periodic table, there's a bold zigzag line that goes down, about two-thirds of the way over towards the right. There's a bold zigzag line. Those boxes that touch the line are our metalloids. Okay, so on either side, directly up against the zigzag line, those are metalloids. And then all these on the right that don't touch the line, those are nonmetals. So metals are in the middle and the left, metalloids are on the zigzag line, nonmetals are on the right, plus hydrogen. So you can look at an element, decide where it is on the periodic table, and have a decent idea of what group it's going to go into.